Hello everyone. Welcome to USENIX LISA21. Thank you so much for joining me today. Today, I'll be focusing on a talk called Practical Kubernetes Security Learning using Kubernetes Goat. Just a bit disclaimer. Today, I'll be using completely no slides and trying to showcase you the real world and the practical way how you can go around and set up the Kubernetes cluster and try out Kubernetes Goat to learn and understand what kind of different security issues which will happen in the Kubernetes clusters in day to day from my experiences or some of the real world simulated scenarios and see how we can learn from these security issues so that we can go back and apply these principles to defend our clusters and secure them in a day-to-day environments. So before we dive in, little bit about me. Myself, Madhu Akula. I have been working around Kubernetes and containers and cloud security research for quite some time and trying to share my knowledge by presenting a bunch of conferences around the world like Black Hat, DEF CON, USENIX, some of them. And apart from that, I have actively involved with communities and also trying to contribute my research by finding vulnerabilities and giving back to open source communities and pretty much learning day to day everything new. That's bit about me. If you wanted to follow me or learn more about me, you can find in social media, Twitter, and some places. So without further ado, let's get into the Kubernetes Code. As you see, Kubernetes Goat is an open source project which is completely created out of it, the use case where we wanted to learn and teach about Kubernetes security use cases, right? So you can find the documentation here, which is available, and you can follow the step-by-step guide and detailed information at Kubernetes Goat documentation. So before diving into Goat, what exactly is Kubernetes Goat, right? So Kubernetes Goat is designed to be intentionally vulnerable, which means it has known security issues and vulnerabilities to learn and teach about Kubernetes security in a practical way where the users or the people who want to learn and understand security, they will go ahead and set up intentionally vulnerable environment so that that has already existing vulnerabilities. Now it's their job to understand how these vulnerabilities get exploited and how they can go and fix these vulnerabilities by trying out some hands-on scenarios. Right. So big disclaimer and warning, as Kubernetes Code is intentionally vulnerable, please do not try to deploy this Kubernetes Code in the production environment alongside your sensitive stuff. Try to create a testing environment, or I will showcase in a minute how we can set up this in online without any cluster environments in a free way. Right. A bit about it. So this Kubernetes Code is designed in different scenarios way. We will be bit looking in a soon how these scenarios look like. So let me go back into each of these scenarios in a bit. If you're someone coming completely new to the Kubernetes environment or someone haven't heard about Kubernetes or something, I would highly recommend you to learn about Kubernetes. At the end, security is nothing but if you don't understand the technology, you can go ahead and apply much more your practice skills into the technology itself, right? So Kubernetes itself is an open source container orchestration system for automating application deployments and scaling and its management. Basically, it was designed originally at Google called Project Borg, and then it is later on moved to Cloud Data Computing Foundation, and it maintained by CNCF right now. Right. If you are someone really completely new to Kubernetes, I highly recommend this children's guide to Kubernetes, which is very simple video explaining in a fun way and very interesting way to learn about Kubernetes itself, right? If to give us some context before we diving into the security parts, this is very high level overview of how Kubernetes cluster look like in an environment, right? Typically, there are two levels of thing. It's like master and slave or master and node conversations, where master is kind of brain and where it is the control, and the nodes are the acting place where your pods or services or containers will get deployed. Right? There is so much terminology you will be hearing, but I think once you get understanding, I think it will be much more easy to understand about the Kubernetes and its security parts. Right? So to just give a context, so Kubernetes master has a very high level 3 to 4 components. One is API server, which is one of the key or brain of the Kubernetes. Each and every operations, which can be talked from external users or within the Kubernetes components itself, has to go through the Kubernetes API server. Once API server sends the request, it will go ahead and send it to the control manager scheduler, and it will also store in the etcd, which is a data store, right? So if you're as a developer or operations team, you are wanted to go ahead and deploy application or service into the Kubernetes cluster, then you will go ahead and ask your API server to the Kubernetes and saying that I wanted to go ahead and deploy a specific service, right? Then it will go ahead and ask control manager, I wanted to go and maintain this desired state, right? Similarly, scheduler makes sure, okay, do we have enough resources in our nodes? Do we have enough memory CPU consumptions, right? So it will ensure that it will validate and go ahead and schedule those pods in one of your nodes according to the availability, right? So the etcd is the database which will maintain the state, whatever the changes which you are managing in a data plane, right? Like where you can store and read, right? So when you come to the node side, which is the non-master nodes, it ideally contains kubelet, which is basically to talk to the Kubernetes API server and the runtime. The runtime is basically where you run the containers, the container runtime, right? The deeper you go, there are quite a lot of interesting things happening around the Kubernetes space. So they have abstracted the container itself, different runtimes as a CRI, which is like container runtime initiative. Similarly for networking, storage, bunch of things. But in this focus today, we will be focusing on Kubernetes high level and see how we can think about security issues around the Kubernetes cluster and its environments as well. Right. If you are someone wanted to more understand deep dive into Kubernetes, I would highly recommend check out this official documentation by Kubernetes itself. It's pretty well maintained and very detailed and document friendly. And also you can try out some of the tutorials they have, which are again hands-on. You can go ahead and try out this setup and understand more about how you can deploy and practice Kubernetes itself. There is a really interesting example by the Kubernetes by examples where it will try to explain you specific concepts. What exactly is pod, how we can deploy, and all these kind of very small informations in a simpler and nicer way, right? Cool. For this Kubernetes code session, we assume that you have basic fundamentals of Kubernetes and also understand how to run a simple application into the Kubernetes cluster, right? So if you wanted to set up your own Kubernetes cluster environment, feel free to go ahead and set up your own environment. But if you are someone who doesn't have the setup or like it doesn't have the resources, I have also created something called Katakura Playground, which means that if you are someone who wanted to learn about Kubernetes security and try out, you can also go ahead and click on this Katakura Playground, which is completely free and set it up in online. You can go ahead and try out here. Let me go back and change into presentation mode. Thanks to the Katakura team, we can go ahead and deploy this entire Kubernetes Goat setup in a online in a free way, right? So let me go ahead and click on the launch, which is basically to set up the Kubernetes cluster itself. In the same time, you can also go through the documentation. If you are someone already have your own cluster and wanted to set up, like this is an example. If you wanted to set up your own cluster in Google Cloud, you can skip this. Yeah, if you are someone who already has the Kubernetes cluster, then you can also follow these prereqs. You need to have a kubectl setup, which is a Kubernetes CLI utility to talk to the Kubernetes cluster. And also we need to have a Helm version 2, which is the older version of the Helm, to showcase one of the vulnerability and security issue in this scenario, right? Then you can go ahead and clone the GitHub repository, and you can go ahead and run this setup script, which will set up the Kubernetes code, right? Cool. Looks like our Kubernetes cluster is set up here. And let's go to the Kubernetes code, which is cloned locally here for our demo and session purpose. And if you are using this Katakura scenario, you can also go ahead and set up using the same way. And I will go ahead and hit the setup script, which will go ahead and deploy the Kubernetes code into our Kubernetes cluster. It will take a bit time due to the reason it has to deploy a bunch of different services and the pods and containers and applications, right? At the same time, for the sake of the demonstration, I have also created a local setup. You can go ahead and do kubectl get pods. You can see bunch of pods running, which is nothing but our entire Kubernetes code setup is up and running, right? So I think it will take a time if you are someone who is using Katakura or anyway, even in the local setup, because this I have already started the scenario setup. So that's why it is already up and running. So make sure you see all these parts are running state, or some of them can be completed, especially if these are the jobs. So make sure you have the state maintained, so that which means that you have all the tools and things that set it up and running for the Kubernetes code, right? So you can also go ahead and check here as well. You can click on kubectl get parts. You can see here some of them still container creating state and some of them completed. I think once everything is done, you can go ahead and click this access Kubernetes code, which will go ahead and expose these applications and services into locally, so that you can access them in a local environment, right? So I have gone ahead and run the access script, which is just to expose those apps locally. So you can see me now. Uh, access all the ports are exposed. So now I can click and open those things. So which is the Kubernetes Goat cluster environment setup and up and running, right? So now you can see all the scenarios locally here itself within the cluster, which means you can go ahead and play about these scenarios and understand how it works, and learn about how you can exploit them, and how attackers can leverage these to bypass and gain access to your Kubernetes clusters, right? So to go back to the session, I'll be leveraging and using the guide, which is available in this section. So I will be leveraging this to follow through some of the scenarios and showcase you different kind of practices, right? So there are quite a lot of scenarios, which I don't think so I will be able to cover in the today's session. And by the way, I will be keep releasing these scenarios. And if you see something which is missing, and please feel free to make an issue or raise a PR. Happy to contribute and look after these scenarios and improve this. Right. So let's start with one of these scenarios, and this is very quite common. If you see most of the modern days development, most developers use GitHub or like Git as version control systems to write the code and deploy into production systems, right? So this scenario is basically to showcase the similar kind of vulnerabilities and issues in the real world, right? Like if you go ahead and click on this the scenario, it will go ahead and give you the how you can get started with the scenario and some context around the scenario to solve these challenges, right? In this case, sensitive keys in the code bases. Developers tend to commit sensitive information to version control systems. As we are moving towards CI/CD and GitHub systems, we tend to forget identifying sensitive information in code commits. Let's see what we can find there, right? So this is nothing primarily specific to Kubernetes, but in general, security best practices, which we commonly see in the Kubernetes or CI/CD environments, right? So welcome to the build service. This service is built using containers with CI/CD pipelines and modern toolset like Git, Docker, AWS, and many other, right? So you can, as an attacker, generally what we will do in a real world is we will go ahead and check is there any robots.txt is available. There is nothing. And we will also look after is there any other files like readme.md or similarly like it. Sometimes we also look at like is there any git folder which is lying, and also look at is there any config. This is very rare, and this will take quite amount of time by enumerating different kind of directories and common file paths. So here, if you see, we kind of see a Git configuration repository available. So as an attacker or as a general security person, it's quite interesting for me why the Git config is available, right? So here I will going to borrow a bit about documentation and see how we can learn. So I'm going to use a simple utility called Git dumper, which is to help to clone the entire GitHub from the remote place. Let me go ahead and install Git dumper, which is going to help me to set up and download the remote GitHub repositories. Now Git dumper is there. So to clone this, I just need to use Git dumper and the URL which I have to clone, right? In this case, it's this is the URL and .git and what is the service build code. So I just wanted to give a name. So what it does, it will go ahead and finds this remote GitHub repository and fetches into a local system. Now, if you go back and see into a build code, which is what we downloaded, now you can see the complete application is there with the .git folder. So as an attacker, now it's up to you to understand what exactly it is there. You can also do git log. It'll showcase the previous commits and version information about this application, and try to read the app, because now you literally have the complete source code access, right? So now it's basically as a simple vulnerability, which is due to the Git is available. As an attacker, we can able to completely clone the entire repository and gain access to the source code as well, right? So this can be a bit more leveraged into a depth as well. Like if you see one of the old commits of the Git, so generally, they have a sensitive environment variables, right? So if you wanted to go back to specific commit, you can check out to that commit. And now if you look at like the Git, so now you also see an interesting file called cat.env, which is where you found the AWS access key and secret key and our flag, which means that developers are like the one of the user has mistakenly committed these keys into GitHub, and it is removed, but due to the version history, like version control system, it maintains the history, so we can still see these secrets lying out there, right? So this is one of the common cases which we see in the real world day-to-day Kubernetes clusters or CI/CD environments, where we see a lot of sensitive information committed and not cleared, which are lying out there in the containers and Kubernetes services, right? And there is another way also which you can achieve. So this is another different methods. So that is where this guide is pretty useful. So I have tried to document them, how we can exploit these scenarios and learn about securing them or attacking them, right? In this case, if you wanted to see, so we are trying to basically export the pod name and executing into the pod which is running. So if someone you are going to assess these clusters in a real world, so you can also use this method. And there are utilities like Trufflehog, which are like an open source tools to identify sensitive information in a version control systems or in the file systems, right? So we will go ahead and run a Trufflehog in the place where the app is running. What it does is it will go through all the Git history and identifies any high entropy values or sensitive informations, right? So looks like it's going to take a bit of time. Let's wait for the results. Yeah. Now you can see interestingly, the flag and output is available for us. We can see this, it already got detected, whatever the secret which we have due to the high entropy region, right? So this is another way to solve this challenge or like scenario in our case, which we are trying to teach you how to identify sensitive keys or secrets in code bases, right? So similarly, there are quite a lot of other scenarios in Kubernetes code to learn about like how Docker in Docker. This is one of the common scenario where we see in real world. We as a developers or operations team wanted to build containers in a build systems like Jenkins or CI/CD, like Bitbucket pipelines or GitLab systems, right? So in that case, most of the operations team are the setups in a way that where they will expose some kind of Docker socket, right? If you look at this an example, maybe we can go ahead and try this scenario. You can click on this thing. So there is a vulnerable like environment which is asking like enter your server address. So whenever you provide address, it clearly looks like our ping command output, right? Similarly, you can also give with the semicolon separated, because in a Linux you can give two different commands. You can also perform ls command. Now you can see after you executed the ping command, it also executed our ls command, right? So which means you can also give like ID, which means to just know which kind of user it is running. So by this means you are literally running with a container with root user, and the application which is running inside the container is vulnerable to something called remote code execution, which means you can execute any code which is going to run inside this container or the server where the application is running, right? So from there, as an attacker, you can go ahead and mount the volumes which are available in the system and download a Docker binaries. From there, how you can exploit and escape out of the container to access the host systems, right? So these are predefined solutions. If you are someone wanted to learn and understand yourself, You don't need to look at the solution scenarios, and you can directly go ahead and try exploiting these scenarios and learn more about the Kubernetes security, right? So to just showcase this example, maybe I can showcase you the example. I'm trying to look for the mount volumes where I can see that there is a tempfs which is mounted with the custom Docker socket. You can see, which means the Docker socket, which is used from the to build the containers, has been available in the mounted in the container or the server, which is going to run these commands, right? So as an attacker, for me, I just want to now download the Docker so that I can able to interact with this socket. So what I'm doing here is I'm going to download the static Docker into the container or the server where it is going to run, right? So this might take a bit time. I think it will go ahead and download this package and save it into the container in the temp folder, right? Let's just wait for a bit. And I think by the time it will be downloading into the local system. Cool, looks like it's downloaded. Now what we have to do is, now it's saved into a tar.gz file. Now we have to extract that. So let's go ahead and extract that file. So it'll go ahead and extract that into a local file system into the temp folder. Now once it extracted, now we can able to access the Docker binary using temp Docker, the binary. And also we know that the custom socket is mounted at /custom Docker sock, and we can use this with -h flag to pass the host socket, and you can perform whatever the commands which you can able to pass it to the Docker itself, the binary or the command which is available, right? With this, you can literally able to run any command and also go and exploit and access to the host system, which means that whatever the underlying host system which is running your container, you can still able to gain access and perform more attacks and privileges in the Kubernetes or container world, right? So let's go ahead and see. Looks like it's still extracting the Docker which we downloaded. Let's take a bit of second. Or it might even stuck as well, as you know, these are not responding. Let's go ahead and refresh and see if the first of all the temp directory has the Docker. Cool. It looks like it has already. Perfect. It has the Docker binary. So let's go ahead and now use our existing commands and go ahead and run the Docker PS with the socket available. Awesome. Now you can see that the containers already giving the output. Maybe you don't see in the specific format. Now you can see test is running, MongoDB is running, MySQL is running, and literally you can able to perform bunch of commands. So now, which means that you have access to underlying host system. So you can even literally go ahead and run your own container and set a backdoor which will connect back to your CNC server, and you can go and further exploit before. And this is a command to see what all images available in the host system. There are quite a lot of images which are available. So let's go back to the previous section. So that's kind of pretty much with this scenario. But as an attacker, you can go ahead and beyond, you can exploit furthermore and gain more and more access and control to the systems, right? Cool. There are more and more other scenarios as well. I don't think so I will be able to cover in this today's talk or session, but I'm really happy if you wanted to go back and try out them. All the documentation is available and learn more about these scenarios, right? So as part of this, let's also go in and understand how you can get different kind of security checks issues, right? So you can also identify different kind of vulnerabilities, which means that you can also go ahead and understand what is the higher level of maturity or security risks possibly available in the cluster. So there is a really good example called Cs benchmarks, which are basically to help you to understand benchmark standard. What are the security risks which are there in your Kubernetes cluster, right? To run this thing, the system, the Kubernetes Goat repository itself has this file. You can go ahead and apply this into your Kubernetes cluster. which will going to deploy something called daemon sets. So if you type kubectl daemon set, it is going to give you the output. So what daemon set means is nothing but if you have multiple nodes, each node makes sure one of this pod or service going to run this in that node to ensure it is going to run in the all nodes which are available, right? So it looks like it's already deployed. Let me go ahead and get the pods to ensure the pod is running. It is still taking a bit of time. It is downloading this container. I will just monitor once it will create. It's taking a bit more time. Maybe I can go ahead and try here as well. Kubectl get pods. Yes. Let me go ahead and deploy the daemon set for the. Yes, there we go. And get pods. It is creating. So once you get the daemon side, you can exec into the Docker container, like the one which we just created. Kubectl get pods. Yeah. Then kubectl exec Docker bench security, and you can do the. I think sh shell script is there. Looks like it's still creating. Let's see. Yeah, here it is done. Let's go ahead and do kubectl get pods, kubectl exec -it, which means interactive tty exec means execute into the container or the pod in this case, and run this command which is shell, right? So now we are inside the container. I think here also you can do the same now because it's already done. So now what we have to do is now the container is already running. Now we just need to go ahead and run our Docker bench security script, right? Which is inside Docker bench security and Docker bench security.sh, right? So what it does is it will go ahead and run these security checks in the nodes which are running in the underlying system and understand any security best practices which is missing or it is not following any the best practices as per the Docker Cs benchmark standards, right? It will definitely take a bit of time. So I will go ahead and leave this scenario and we'll come back and see the results, right? Similar to Docker Bench, so there is also Kubernetes Cs benchmarks. You can go ahead and run these Kubernetes Cs benchmarks for both master node and the node itself. So understand what are security risks and how you can fix them and improve them, right? And there are quite other scenarios as well where we see in real world how attackers leave private registries unopened and how we exploit them to gain access to those registries and a bunch of other things, right? So the one interesting thing which we have seen, and I think which is currently going to be fixed in most of the clusters, but we still see in one of the oldest clusters when we do pen testing or security assessment, is Helm. Helm is a package manager to deploy applications and services into Kubernetes cluster. In the older version of Helm, which is the version 2, by default, whatever the Helm which is going to deploy has a complete cluster admin privileges or back account, which means the role which is going to get for the Helm, the server side component is called Tiller. Tiller is the service which is going to talk to from the Helm, so which has full permissions to do in the Kubernetes cluster, right? To showcase how if you find these kind of vulnerabilities or Helm version 2, attacker can get complete cluster admin access, right? In those cases. So we can show a simple demonstration how it can be done. So let me open a simple terminal here again. And let me put it in presentation mode and maybe a bit bigger screen. Okay. So let me go ahead and run a simple container, which is nothing but to showcase the Helm Tiller exploitation. This is another simple container which basically has a predefined Helm chart and which is going to use and Helm tools already installed inside it. Right? Cool. So now we have cluster. So what we are going to do is we are first checking if the tiller component which we have in the Kubernetes are not, right? So we can use telnet or like NC or any other tools to talk to the tiller deploy. This is the service name, and this is available or deployed in the Kubernetes system namespace. That's why we are specifying kube system. And the by default port it runs is 44134, which is the default port. And by default, the Helm installs this port on any service can listen, which means 0.0.0.0, which means go ahead and run this. And you can see it is able to successfully connect to the tiller service, which means that server side component of Helm, which is the tiller, is available in the current cluster, which means that the cluster is running older version of Helm, which means that attacker can now completely gain full privilege of the clusters and take over the entire Kubernetes itself, right? So let's go back and stop this, and let's use this tiller deploy service and the port to talk to that using Helm itself, because it's easy to talk using the tool which is able to talk to them, right? So now we are using the older version of Helm and using the dash dash host flag, which is going to talk to the host of the tiller deploy, and you can also perform and pass the commands, right? So let me go ahead and copy this command. Looks like this tell is stuck. Yeah. Okay. Cool. So now you can use this command. Now you can see if you specify host flag, you can able to talk to that, because what we are saying is we are saying Helm to go and talk to this host of the tiller, right? So if you remove that, it will say that by default it is talking to the specific host. So it is going to return the server version and the client version. Now what we are going to do is before we deploying one of the pawn chart, like which is going to deploy a Kubernetes security chart, right? So we are trying to perform the operations like kubectl get cluster, the secrets. Looks like the chart. I think I have already deployed. That's why you can see me secrets all coming. But let me showcase the same scenario in the local setup. Sorry for the confusion. So what I'm trying to showcase is I'm first trying to deploy the tiller, which is the server-side component of Helm. And now I'm trying to showcase if the Helm is able to talk to the tiller service, then I'm trying to showcase whether you can able to get the secrets from the Kubernetes cluster. By default, you should not be able to retrieve the secrets from the Kubernetes system from this container, which is running in the default namespace, right? Because we are requesting from kube system namespace, which is from a different place. And this also doesn't have the privilege to do. So now what we are going to do is we are going to deploy a simple Helm chart called pawn chart. I will go ahead and showcase what this chart does in a bit. So if you see, the chart has been deployed. Now, if you go ahead and run the same command to get the secrets, now you can see you can able to get the secrets from the Kubernetes cluster. Not only secrets, you can able to do basically all the operations which you can do as a system, cluster admin as a Kubernetes, right? So what we have done is we have went ahead and deployed a chart called pawn chart, which is nothing but it will go ahead and create a cluster role with full privileges to all the API groups and all the resources and all the permissions. And it will go ahead and bind this role to uh, like the default namespace, right? So it is going to use this cluster role, whatever the role which we created, and go ahead and map this to default namespace and the default service account, which is nothing but what we passed in the values, which is saying the default namespace and default service account. So by default, these service accounts are going to map in the your own system in the var run secrets kubernetes.io and the service account, and I think the token. Then this is the JWT token which is going to use, and this is the namespace which is nothing but a default. So what we just deployed the chart is it'll give all the default service accounts in the default namespace full cluster admin privileges, which is we have just deployed, right? Which means that now you literally can able to gain access to the complete cluster as a cluster admin, right? So this is quite a complex and very security completely takeover of the Kubernetes. So these kind of attacks will give you attackers complete takeover of the other services, even the data and all the resources, right? So it's quite dangerous. So if you look at back to the previous checks which we just ran, the Cs benchmarks, the results are out. So you can see there are quite a security issues. It is trying to return, like there is a warning saying that the Docker daemon audit is not enabled, and you are not auditing the specific directories, and also some of the things already passed, the permissions are properly set, and also you see some of these containers are running as a root, which is dangerous. Like that, you can completely get the detailed information of what are the security issues at a higher level posture using cs benchmarks, right? And I think that's pretty much I can cover scenarios, but I would highly recommend you to go back and give it a try. And feel free to let me know if you have any issues. There are really interesting scenarios how we can bypass the namespaces and access other microservices and perform DOS attacks on the resources utilization and many other things in a hacker container also, which is specifically designed to perform container and Kubernetes cluster security assessments, right? So with that, you can also make sure tear down your cluster if you have completed. If you are using this Katakura scenario, you can just close it down. I think it should be completely fine. But if you are setting up your own, make sure you are tear down your cluster and remove all the things which you have deployed in the cluster. Right? As part of this Kubernetes code, I have also performed a bunch of examples. Like I have created a security reports from the tools, which is very useful while you wanted to scan for any known issues in your Kubernetes manifest as well, right? Some of the results also you can find here, which is quite useful as you can use these tools in a day-to-day environment while you scanning for security issues in your CI/CD systems as well. Like another report from checkover tool, and you can see all the issues which is identified and security misconfigurations which are available in this thing. All right. With that, thank you so much once again for joining this session. And you can find and learn more about this project at the Kubernetes Goat. And please go ahead and give it a try. And you don't need to set up yourself. Use the Katakura online playground, which is already available. And please feel free to leave your feedback and let me know if you wanted to add anything and reach out to us. Thank you so much once again, and I hope you have great sessions at USENIX Lisa, and looking forward. Thank you.